Hi everyone, I am Bhavna, 5th semester, Electronics and Communication Department of Sri Venkateshwara College of Engineering. Today, let us deal with the subject electromagnetic waves. In that, let us deal with the topic concepts of electromagnetic and its application. Introduction. Electromagnetic waves Electromagnetic waves are produced when an electromagnetic field comes in contact with the magnetic field are called as electromagnetic or EM waves. They are a composition of oscillating magnetic and electric fields that can be studied using Maxwell's equations. Electromagnetic waves can be radio waves, microwaves, television waves, and more. The differing types arise from the difference in wavelength and frequency. How are electromagnetic waves formed? A charged particle gives rise to an electric field. This electric field appears a force on other charged particles. Positive charges get accelerated towards the direction of the electric field. Contrastively, negative charges gets accelerated in the opposite direction. The moving charged particle gives rise to a magnetic field. This magnetic field exerts a force on other charged moving particle. As a result, an accelerating charged particle gives rise to an electric field. Therefore, you can see that electromagnetic waves are magnetic and electric fields traveling via free space with the speed of light c. When the charged particle accelerates around an equilibrium position, it is termed an accelerating charged particle. So, if its frequency of oscillation is f, the electromagnetic wave it produces will also have a frequency f. Properties of electromagnetic waves. Following are some key postulates regarding electromagnetic waves. Electromagnetic waves are transversive in nature. An accelerating charge can produce them. They require no medium for propagation. The direction of variation of electric and magnetic fields are perpendicular to each other and are perpendicular to the direction of propagation. Electromagnetic waves example and their uses. The electromagnetic spectrum includes the several electromagnetic wave types. Here is in detail about each one of them. Radio waves, the wave with the longest wavelength among all the EM waves. They can be foot long or even up to several miles in length. These waves find application in data transmission via radio, satellites, computers, and radar. Microwaves. Shorter than radio waves, these microwaves pressure in centimeters. They are extensively used as they can penetrate smooth clouds and light rain. The universe has immense cosmic microwave background radiation that scientists cannot connect with the Big Bang. Infrared waves. In between microwaves and visible light regions, infrared waves are often classified into near and far categories. Near infrared waves lie closer to the visible light and they find applications in TV remotes to switch from one channel to the another. Far infrared waves are all away from visible light in wavelength and give off heat. Visible light. Visible light spectrum than the human eye can see is called as visible light spectrum. It covers wavelength from 390 to 700 nanometer. Ultraviolet waves. UV rays are the next shortest wavelength rays largely emitted from the sun. The ozone layer protects the earth from the sun's harmful ultraviolet rays. Often, some insects like bumblebees can see ultraviolet light. Powerful telescopes use UV rays to see the stars. Propagation of electromagnetic waves. The electromagnetic waves can be propagated from the transmitter to the receiver in the following waves. Ground waves. They can be propagated along the surface of the ground and the process is called as ground wave propagation. Sky waves. When the EM waves are propagated via sky, it is called skywave propagation. In this type of propagation, the waves get reflected back to the earth from the ionosphere. Space waves. EM waves often they propagate from the transmitter to the receiver antenna without any reflection or refraction. Then it is called space wave propagation. Application of electromagnetic waves. Following are the few applications of electromagnetic waves. Electromagnetic radiations can transmit the energy in the vacuum or use no medium at all. Electromagnetic waves play an important role in the communication technology. Electromagnetic waves are used in radars. UV rays are used to detect the forged banknotes. Real banknotes didn't turn the fluorescent under UV light. Applications of electromagnetic waves. Electromagnetic waves are also known as EM waves. Electromagnetic radiations are composed of electromagnetic waves that are produced when an electric field comes in contact with the magnetic field. It can also be said that electromagnetic waves are the composition of oscillating electric and magnetic field. Electromagnetic waves are solutions of Maxwell's equations, which are the fundamental equations of electrodynamics. What are electromagnetic waves and how they are used in everyday life? Electromagnetic or EM waves are created from the variations between the electric and the magnetic field. EM waves do not need a medium to propagate, making them ideal for information transfer. For example, electromagnetic waves are used for radios, television, and medical imaging devices in the everyday life. Formation of electromagnetic waves. When a charged particle produces an electric field, the produced electric field exerts the force on the other particle, leading to the negative and the positive charges. When these charges are accelerated, positive charges move in direction of the electric field, whereas the negative charge tend towards the magnetic field direction. Electromagnetic waves, a combination of magnetic and electric field, are produced by accelerating charged particles. Electromagnetic wave equation. The electromagnetic wave equation describes the propagation of the electromagnetic waves through a material, medium, or vacuum. It is a second order partial differential equation and is of 3D form. Additionally, the intensity of an electromagnetic wave is defined by the formula E is equal to P by A, where P is a power and A is defined as an area. Conclusion. Electromagnetic waves and the application of electromagnetic waves cover an essential aspect of physics. Numerous things use of electromagnetic waves as covered under the applications of EM waves. Electromagnetic waves are composed of photons that pass through an material, medium, or vacuum. When these waves pass through the medium, some waves are reflected whereas others are absorbed. So it is a diagrammatic representation of electromagnetic waves. So thank you for the session.